Hello, welcome to this video. Today we're gonna take a look at this problem. So we have two endpoints that are sitting on a circle. In this case, n is equal to 4, so we have 8 points, such that their index represents their position on the circle. So we have A1, then A2 is the one right next to A1, then A3 is the one right next to A2, then A4 is the one right next to A3, and so on. Alright, we order the points into n pairs, and for each pair, we evaluate the length of the segment between these points. So we're ordering these into, say, 4 pairs, and I should say 4 distinct pairs, such that all points are in the pairs and no point is in 2 pairs simultaneously. So I can choose like A1 and A3, A2 and A7, A6, A8, and A5, A4, and I evaluate the length of the segment between the 2 points of each pair. So I would have evaluated the length of A1, A3, the length of A2, A7, the length of A6, A8, and the length of A4, A5. And the next thing we're told to say is that we add all of those up to get a final value. So we would have calculated all of those lengths, and then we would have added them up into a single value. Show that this value reaches a maximum when the pairs chosen are A1 and AN plus 1, A2 and AN plus 2, all the way on up until AN and A2N. So first of all, it may seem pretty intuitive, that like these are sort of like the biggest segments, but there are some cases that it's not immediately obvious why that would be true. Like here, if we take A1, A5, A1, A5, A2, A6, A4, A7, then A3, A8 is this small segment. Supposedly it would have been much better to take, say, A3, A6 or A3, A5. But what we're going to show is that no, it always reaches the maximum when you take like the one opposite to A1, the point opposite to A2, and like we order these up. So the first thing we're going to do is the simplest case that is not immediately intuitive. So for n is equal to 1, the case is obvious because we only have 2 points and there's only one way to put them into one pair. So there's nothing interesting there. So what we're going to do is for n equals 2, show that this is true. So let's say we have a circle and 4 points on it, A, B, C, and D. And I also should mention, the points on the circle are not necessarily evenly spaced, right? A1 can be very close to A8, but then A4 can be very far apart from A5, right? These distances don't have to be the same. So just to clarify. So we have 4 points A, B, C, and D, which is also their order on the circle, A, then B, then C, then D. We want to show that AC plus BD, that the sum of these two lengths is bigger than AB plus CD and AB plus CD, which is one way to take 2 pairs, which are not the diagonals, and it's also bigger than AD plus BC. So what we're going to do is, since AC and BD are the diagonals, they have an intersection point E inside the circle. And so from this, we know that by the triangle inequality, the sum of the lengths of 2 sides has to be bigger than the third. So AE plus BE is bigger than AB, and on so this is on triangle ABE, and on triangle DCE we have something similar. CE plus DE is bigger than DC. And now since these are both bigger than, right, this sign is the same on both of these, we can add those up and this will still be true. So AB plus DC is smaller than, we have AE plus BE plus CE plus DE. Well, what is AE plus CE? That's AC. And from the segments that are left, BE and DE, what is their sum? BD. And so we got that AC plus BD is bigger than AB plus DC. Right? So, so we have AC plus BD is bigger than AB plus CD. And similarly, we can, if we look at the other two triangles, AED and BEC, we can get that AC plus BD is also bigger than AD plus BC in a very similar way. Alright, so we prove this for n is equal to 2, right? Because these are the only three possible options we can have. The diagonals or the two pairs of opposite sides. Alright, so now let's understand this for the general case when we have two endpoints. So first of all, what this tells us is that for any 4 points, if we have A, B, C, D such that like 2 pairs are chosen from A, B, C, D, then the maximal value that we can get from these 2 pairs is if we make the 2 lines cross, right? That's what the diagonals mean. We want the lines to cross inside the circle, the segments to cross. So here, let's say we have something like this, right? So these are the pairs we chose. We can take any 4 points, and if 2 pairs were chosen on there, but the lines aren't crossing, then if we change it to so that they are crossing, we're increasing the overall value, because the others are staying the same, but we're increasing their sum, the sum of these lengths, so the overall sum is increasing. Right, so like here, take A5, A6, A7, and A8. We chose here 2 pairs, A5, A8, and A6, A7. But as you can see, their lines aren't crossing. And we want them to cross in order for the sum to be as big as it can be. So we're going to change it so that A5 and A7 and A6 and A8 are now crossing. But now, take a look at these 2 pairs, A1, A3, and A5, A7. Again, so we have here 2 pairs, but their lines aren't crossing. So we're going to change it so that they are. Okay, so, and now let's take a look at A2, A4, A6, and A8. There are 2 lines that on 2 segments that are crossing. So let's change it so that they are crossing. And here we can't do this any longer. If you take any two lines or segments here, you'll see that they cross at a point inside the circle, meaning that we can't increase this any further. and we got here that this is the arrangement A1, A5, A4, A8, A3, A7, A2, A6, which tells us not that this is the maximal possible configuration, but that this is bigger than the original configuration. We want to show that from any configuration, we after doing this enough times, we will always have to end up with this. Alright, so first of all, the final state is the one where any two segments are crossing. So, right, and so what we want to show is that the only configuration which has this property that any two segments are crossing at a point inside the circle is the one when we're taking A1 to A5, A2 to A6, A3 to A7, and A4 to A8. Right, or in general, A1 to AN plus 1, A2 to AN plus 2, all the way on to AN and comma AN to N. Comma A to N. Okay. Because if we show that this is the only configuration, that means that any other configuration will have to have two segments that aren't crossing, and we'll be able to change it so that they are. And because we're always increasing this value by 1, and this value obviously has a limit, right? We have a finite amount of points here, finite amount of segments, and as they have a final amount of crossings between any two segments, then eventually we'll have to get to the maximal, which will have to be this configuration. So to summarize, the one thing left to show here is that the only configuration where any two segments are crossing at a point inside the circle is the one asked about in the question, AN plus 1, A2AN plus 2, up until AN, A2N. So let's show this. So let's try to understand, we have A1, and let's suppose this is a general case, so I'm going to refer to A5 as AN plus 1. So let's suppose we have our point A1, and we want to understand how to connect it so that any two pairs are crossing at a point inside the circle. So we want to take A1 and C, so we want so here, as you can see, we're passing the line A1, A5 segment, and the three other segments are A4, A8, A2, A6, A3, A7, so that so on every segment, the 2 points are on other sides of the circle, right? A1, A5 divides the circle into 2, and now and there are no 2 points here that are also on the same segment. And that makes sense, right? Because if they were, then these two couldn't cross. So if we want A1 and some other point to cross with every other segment, we want that all the, say, starting points will be on one side, and all the end points will be on the other side. And so we want the number to be equal, right? Because if it wasn't equal, then if we, say, took A1 to A4, then we have 2 points here, but 4 points here, so it'll have to be two. So at the best case scenario, there will be 2 segments, A2 to say A7, A3 to A8, and then A5 to A6 will have to connect. Right, so we want the numbers on both sides to be equal. But if we're choosing A1 at some other point, that means we have left 2n minus 2 points. And we want it so that half of them are on this side and half of them are on this side. So we want n minus 1 points here and n minus 1 points here. But that will mean that the point we're choosing will have to be the one in the middle, aka an plus 1. Right? We'll have n minus 1 points here, which will be a2, a3 up until an. And then then the next point, n plus 1, will have to be the point connected to a1. Because otherwise we won't be able to connect, because otherwise this segment with a1 want to be able to cross at a point inside the circle with any other segment. And so we understand how to draw like the line a1 to an plus 1. But similarly, we can say we want a2 to the point that connects to it to also have that n minus 1 points on one side and n minus 1 points on the other side, which will force a2 to connect to an plus 2. Then a3 to an plus 3, all the way on to an to n. And so, which means that the only configuration which has any two segments cross at a point inside the circle, the only configuration is this one. And so now to reiterate on why that actually solves the problem. So the game we played is take two segments. If they weren't crossing, then like change the endpoints so that they are. And because the only configuration where the maximum amount of crossing is reached, where any two segments are crossing, is this one, then any other configuration will have to have two segments that aren't crossing, which will mean that we can connect them up and increase the number of crossings. And if we keep increasing that number, eventually we'll have to get to the maximum, which is this configuration. So if from any configuration, by playing this game, which we know increases the final value, this final value, we can get to this configuration, then this one is the maximal one. So this one will give us the maximal value. And finally, that's it. If you want more content like this, please subscribe to my channel. I'm uploading more interesting problems and things like this in the future. And finally, that's it.